All right, today we're going to talk about a real classic in software development, something called the V model. Now, its whole reason for being is to put testing right at the front and center of everything. It's all about catching problems super early and building quality in from day one. So let's see how it actually pulls that off.
So picture this. For a long time, the way we built software was pretty simple. You design it, then you build it, and only when you think you're done, you start to test it. I mean, it sounds logical, right? But it kind of begs the question, what happens if you find a huge, show-stopping bug the day before you're supposed to launch? Well, the answer is it gets really expensive and really messy really fast. Finding a deep problem in the design after you've already written all the code? Oof. That means painful rewrites, missed deadlines, and a very unhappy team. And in some fields, it could be way worse than just losing money. It could actually be dangerous. This was a massive headache for the industry. And that right there, that is what we call the late testing problem. It's the central challenge that older methods, like the famous waterfall model, really couldn't solve. And it totally sets the stage for why something new had to come along. This right here shows you the huge shift in thinking. On the left, you've got the old way, the waterfall model, just a straight line where testing is the last thing you do. An afterthought, really. But look at the V model. It asks a revolutionary question. What if we start planning how to test something at the exact same moment we're designing it? You're going from a simple relay race to a much smarter parallel strategy.
And that parallel strategy is the absolute heart of the V-model solution. You can think of it as an evolution of waterfall, one that's been specifically tweaked to weave testing into the entire process, not just staple it on at the end.
Okay, to really get the V model, you gotta know two key words. The first one is verification. This is everything on the left side of the V. The question it asks is, are we building the product right? This is all about prevention. It's about reviewing the paperwork, the design docs, the blueprints, making sure everything is perfect before you even think about writing code. And the other word is validation. This is the right side of the V, and it asks a slightly different but crucial question. Are we building the right product? This is what we usually think of as testing. Running the actual software, clicking around, and making sure it actually does the thing the user wanted in the first place. And this brings us to the golden rule, the absolute mantra of this whole model. In the V model, for every single development phase, there is a testing phase that directly corresponds to it. For every step you take designing, you're also taking a step planning how to test that exact thing. They're basically mirror images of each other. So that all sounds great in theory, but what does it actually look like when the rubber meets the road? Let's take a little journey through the V, from a simple idea all the way to a finished product. And to make this super clear, let's use an example you've seen a million times. We're going to build a login page for an online store. All it needs to do is let a user log in with an email and a password. Super simple, right? Let's see how the V model handles it. Okay, so we're starting down the left side of the V. This is all verification and planning. Step 1, the team figures out the requirements. What does this login page have to do? And at that very same moment, the testers start planning the final acceptance tests. Then, as the architects design the overall system, the testers are right there planning the system tests. Next, when the detailed database design is laid out, boom, the integration tests are planned. So by the time a developer writes even one line of code, the test plans are already locked and loaded. Now, once the code is built, we start climbing up the right side of the V, the validation side. And this is where the magic, the symmetry, really becomes clear. We start with unit testing, which checks the smallest bits of code. Guess what it validates? The detailed design from the other side. Then integration testing checks if the login and the database play nice together, which validates our system design. System testing looks at the whole workflow, validating the big picture architecture. And finally, acceptance testing, where the customer gives the thumbs up, directly validates those initial requirements we started with. See, every step up on the right is a direct check on a step down on the left. It's beautiful. Okay, this whole process sounds incredibly organized and rigorous, because it is. But that brings up a really important question. Is this strict, disciplined approach the right tool for every single job? The V model is your absolute best friend when your project requirements are crystal clear and unlikely to change. It is the gold standard for safety-critical systems. We're talking about medical devices, airplane software, automotive systems, things where a bug isn't just an oops, it's a catastrophe. If top-tier quality, strict regulations, and tons of documentation are your reality, the V model is a fantastic choice. But, and this is a huge but, that same rigidity that makes it strong also makes it incredibly brittle. If your requirements are vague or you know they're going to change, the V model is a recipe for disaster. It's just not built for those fast-moving, agile startup environments where you need to pivot on a dime. And for tiny projects, frankly, all the process and paperwork is just complete overkill. It's a powerful tool, but a very specialized one. When you put them side by side like this, the big trade-off just jumps right out at you. Yeah, they're both pretty inflexible, but the V model's big win is when it finds defects, way earlier in the game. And that one single change has a massive impact on the cost of fixing things, which in turn leads to a much higher quality product in the end. You're basically trading flexibility for quality control. And this isn't just an academic exercise. You see this in the real world, in some of the most important software out there. The code running a pacemaker, there is zero room for error. The system that deploys a car's airbags, it has to work perfectly every time. A core banking system handling your money, security and compliance are absolutely non-negotiable. In these high-stakes games, the V model isn't just a nice-to-have, it's essential. And that really brings us to the final question you have to ask yourself and your team. The V model is an incredible machine for guaranteeing quality through discipline and planning, but that quality comes at the price of flexibility. So the trade-off is right there in front of you. Your project demands top quality, for sure, but can it afford to give up the ability to change? That's the choice you have to make.